20.
20.
Tell me the answers.
First one is B.
Bangladesh.
Yes.
Okay. B and D you say Bangladesh or Dhaka. Okay. Other C I understand.
C, 2C,
Hmm.
3A,
Hmm.
4 Dhaka.
Cross.
Oh, 4 Dhaka.
Cross.
Okay. 5 Dhaka.
Hmm.
6 Canada.
Hmm.
7 C.
Hmm.
8 I did not do.
Question mark.
You said?
When you are keeping anyone blank, you give the question mark.
Okay. 9 also I did not do. 10 I did
Question mark.
Dhaka.
9 question mark.
Hmm.
10 Dhaka.
Dhaka.
Okay. Then
11 Canada.
11 cross.
12 I did not. Okay.
11 cross.
12 I did not do. 13 B. Bangladesh. Sir, and after this 14 I did not do any of them.
Okay, let's start, huh?
Wait, sir, 1 minute. Let me just bring the pen.
Sure. Yes.
Yes, sir.
Yes. Tell me which question you have got.
First one is 4.
4. Okay. You gave 4. You gave which one? Bangladesh.
Dhaka, sir.
Dhaka. You gave which one?
Yes, sir.
Bangladesh or Dhaka?
Bangladesh.
Okay, Bangladesh. Okay. So you know properties of field lines, right?
Yes.
So properties of magnetic field lines. So what is the first property?
They do not cross each other.
Hmm.
They don't cross each other.
Then you have the notes, right? You wrote the notes.
Yes, sir. I have the notes.
Did you send me the notes on topic 17?
No, sir, I did not send in notes. You didn't tell to send them, did you? No.
I cannot remember. Normally I say, for you, I can't remember that I told you to send or not. You send me, huh? As you wrote the notes, I have to check that your writing is okay or not. You
Magnetic
understand?
field lines. Yeah.
Tonight, huh? Tonight you send me the notes, huh?
Okay.
Okay, I
At
gave you
9.
three properties.
Hmm.
One of the properties is magnetic field lines start from North Pole and into the South Pole, right? It is the first one.
Yes, sir. Start from North Pole, end at South Pole.
So I asked you the first rule. Start from North Pole. Look, if you are using this rule, you will get your answer. You gave B, Bangladesh.
Yes, sir.
So I told you incorrect for four.
Oh no, no,
Four
sir.
is
Wait, I
four
say
is B. Yes, correct.
I said Dhaka. I said Dhaka. Sorry, sir.
Oh, you said that. That's why I told incorrect. The answer is B, Bangladesh. Okay, incorrectly.
Okay.
Okay,
Hmm.
it's showing incorrectly. That one is Bangladesh. You see, the rule first rule is followed for A, D, and C. Only for B it's not following. How? I'm drawing and showing you. You also drew the diagram, right?
Yes, sir. About magnetic field lines. Yes.
Check. I'm drawing. Yeah. Here,
Okay, sir. Hmm.
magnetic field lines start from north and into the south. This line is matching, right? All the arrows are matching with this. Start from
Hmm.
north
Hmm.
or and into the south.
Hmm.
Then
Yes, sir.
if you are going this side, it's not matching for B.
Yes, sir. Got it. Hmm.
Yeah. So this one should be this direction, arrow. Is it clear now?
Yes, sir. Can I just wait 1 minute? Can I just write the explanation?
Yes, yes, sure. It is rule one. You write and you draw. The drawing is helpful. You draw there. You have the worksheet, right? Printed.
Yes, sir.
So this question is not beyond your knowledge, right?
Okay. Yes, it's not.
It's
Hmm.
not
Yes,
beyond
sir.
your knowledge. It's inside your knowledge, but you have to think more deeply. This way, you will see all the questions which you couldn't do or which you did wrong. All are inside your knowledge, not beyond your knowledge.
Sir, why is actually Dhaka not correct? Dhaka
Dhaka,
correct.
Dhaka
Shouldn't
is
it be like towards the North Pole?
yes, yes. Look, we are going from north to south, right? So while we
Yes.
are going, the direction of field is like this. Okay, that's why the arrow should be towards this direction. Is it clear?
Hmm. Hmm.
Because this is showing you the compass's needle direction, right? This arrow,
Hmm.
and compass's needle will be aligned with the field lines.
Okay. Okay. Hmm.
Is it clear now?
Yes, sir. Sir, can you repeat the sentence? Compass needle always.
I'm writing. Compass needle needle always will align with field lines. Is it clear now?
Yes, sir.
Then next,
8, sir.
8. So you kept it blank.
Yes, sir.
Okay, P and Q represents two parallel straight wires carrying currents into the plane of the paper. P and Q exert a force on each other. P and Q exert a force on each other. Which arrow shows the force on Q? So this one is not directly beyond your knowledge, it's indirectly in your knowledge. Like you know right hand grip rule, right?
Yes.
Right hand grip rule gives you the direction,
Hmm.
direction of current, and also it gives you the direction of magnetic field lines, isn't it?
Yes, sir.
If both the straight wires are into the plane of paper, then you use your right hand, hmm, right hand to understand the direction of magnetic field lines. So check it out here. Uh, is it clockwise or anti-clockwise? Samjit? If you are using right
Yes,
hand
sir.
grip rule, will it be clockwise or anti-clockwise? Magnetic field lines. There will be magnetic field lines, right? Around this wire. This way, right?
Sir, how do we know that if it is clockwise or anti-clockwise?
Right hand grip rule, we got this one, right? Can you remember we had this? So if you are keeping your thumb to the direction of current, this is current direction, right?
Sir, how do we know that the current is upwards?
We are giving, just giving this. We can give downwards, we can give upwards. You have your right hand, you fix your right hand with a grip, right? Then your thumb
Hmm.
is showing you the direction of current. You can keep your thumb downwards or you can keep your thumb upwards. Okay.
Hmm.
Now, for example, we are thinking that the current is going upwards. You did not get right hand grip rule.
Yes, sir. I kinda got it.
Oh, so in right hand grip rule, you got this, right? The diagram also you got, the current direction you got, magnetic field lines you got, right?
Hmm.
So if the current is going upwards, then your other fingers, other than thumb, the other fingers are showing you the direction of magnetic field lines. You see, your other
Hmm.
fingers, if your thumb is going upwards, then your other fingers are showing you anti-clockwise direction, right?
Yes, sir. Hmm.
So that one is a magnetic field. magnetic field anti-clockwise. Is it clear? I'm showing you only one field line. This way there are
Yes,
lots
sir.
of field lines. So it is a right hand grip rule and we are applying a right hand grip rule. Now you tell me if this one is going into the paper, the current direction, hmm, into the paper, then the magnetic field lines will be clockwise or anti-clockwise?
Clockwise.
Clockwise. So it is clockwise. Yes, correct. For both the wires, it is clockwise, right?
Yes. Sir, how do we know that it's going into the paper and not out?
They told us,
Oh yeah, okay, okay, okay.
and it is cross, right? Cross. They are
Hmm.
saying into the paper. If it is dot, then it is out of the paper. Okay, fine. Now they are saying us it is into the paper or out of the paper. That's it. Now for this one also same, right? Both are into the paper. Then here we are getting this way again, right? Clockwise.
Yes, sir. Hmm.
So now look, the arrow direction for this one is upwards here for the left side. It is upwards, and for the right side it is downwards, right?
Yes, sir. Hmm.
So we can understand that their direction, the closer part of the magnetic fields, their direction is opposite, right? Hello.
Yes, sir. Hmm.
So
Wait, sir, can you
if
can
they
you
are
can you
opposite,
can you repeat that sentence?
yeah, the sentence is the closer part of the field lines,
Hmm.
their their direction of arrow is opposite. Like
Hmm.
for this field lines, it is downwards, and for this field lines, it is upwards,
Upwards.
right? So
Hmm.
we are considering that this side is creating north and this side is creating south, or vice versa. We actually this idea I made, okay, north and south. But one thing we understand, these are showing you opposite direction, right? In your
Hmm.
textbook, if you go through, you will find it that they they are showing you opposite direction. That's why they are creating the different poles, okay,
Hmm.
opposite poles.
Hmm.
And as they are creating opposite poles, they will attract each other.
Hmm.
So they will create a force towards D, right? That means one one wire will attract another wire.
Hmm.
So you got it?
Yes, so it should be Dhaka, right?
Yeah, it should be Dhaka, and you take all these notes. This diagram you draw first, right hand grip rule. When applying right hand grip rule, we got these arrows, we got these poles. That's why they are attracting. You write all these points.
Sir, can you say me why it's D? I mean, like
It's
I
D
understood that it's
because their direction of the magnetic field lines are opposite. At the closest part of magnetic field lines, their direction is opposite. So they are creating different poles, okay,
hmm,
or
hmm,
opposite poles.
hmm.
You just make it in your own words, no problem. Because if I say again, I will say in different words. I cannot repeat with the same words because I am making. When I am talking to you, I am making it. I did not memorize the sentences. I just know the
Say,
ideas.
hmm. Sir, what change will make it A or B or C?
Okay, very good question. It is not possible to have A or C. It is possible to have B. B only possible if they are repelling each other. Like one wire is giving current
Into the paper,
into the
and one
paper,
is out
another
of the
one is
paper.
out of the paper. That time there will
Out of
be
paper.
repulsion.
Hmm,
Okay, that time
hmm,
at the closer sides you will find that they both have the same direction of the field lines. So same pole create, then they are opposing each other, right?
hmm.
Is it clear, Tamjid?
Yes, sir. Yes, sir. Hmm, hmm, hmm. Yes, sir. Done. Now nine.
Nine. Nine you can do now. Do by your own.
There. So is it North Pole A?
Yes, North Pole, correct.
I just guessed it. Kind of. So the arrows on the field line show the direction of force on a North Pole. Isn't that the magnetic field? Wait, sir, and these shells, the magnetic, what do you call the direction of current, right?
Sorry?
So are these shells the direction of current?
No, no. Which one?
These circles, these small circles.
Circles are showing you magnetic field lines.
Okay, this I mean the shells.
Yeah, looking like shells.
So these are the magnetic field line, and that X through X the current goes through,
Into
and
the
at the
page.
top of X into the page, and uh, X is towards the North Pole. Like, I mean, if the current goes into the paper at the like at the end into the paper, it will be North Pole. Like, and
No, it's
it will
not like
be
that. You just remember one thing that the direction in the field lines, right?
Hmm.
So this direction of field lines actually showing us, you can consider it as the first rule. At the first rule of magnetic field lines, we got magnetic field lines start from North Pole and into the
Hmm.
South Pole, right?
South Pole.
In that sense, we can take this one as the direction of field lines as the direction of North Pole. Okay.
Kind of. Kind of. I got it. Like the direction of the field lines, the arrows on the field lines show the direction of force on a North Pole.
Yes.
So, is it like, is there anything related to right hand rule here?
Yes. Yes. Right hand rule. Using the right hand grip rule, we are having here magnetic field lines direction that is showing us clockwise,
Clockwise.
right?
Hmm.
Of course, there is right hand grip rule. That's why we are getting clockwise direction. Now, this direction,
Hmm.
what it is similar to, this direction is similar to the direction of North Pole, right? We got in the first rule of North, field lines that North, it starts from the North Pole and ending to the South Pole. And also,
Hmm.
uh, just in question number 4, you got there the direction of the needles
Hmm.
in the compass is showing you the direction of the North Pole, right?
Hmm.
In north, in a compass, the arrow is representing the North Pole, right?
Hmm.
Isn't it? So if you
In
consider
a
all,
in a compass needle or compass only.
yes, in a compass, uh, we are showing the compasses, right? Over there in question number 4. Can you remember? Here,
Uh, yes.
A,
In
B,
question number
C,
four.
D. These are the position of the compasses, right? So the
Hmm.
arrow here,
Represents the
all the
field,
arrows are
magnetic field.
representing the North Pole. All the arrowhead. Is it clear?
Sir, if all the needles, I mean, like
Hmm.
the arrows show the uh, North Pole, but D is showing South Pole.
Which one?
D
D.
Dhaka.
Dhaka. Dhaka
It's pointing
arrow.
towards south.
No, it's look. It's pointing to the south. Why? Because the field lines are going from north to the south, right? So it's
Hmm.
actually following the line of force. Is it clear?
Hmm.
And while you
Hmm.
it's following the line of force, that time you see why it is south here, because its closer end is north, right? That's
Hmm.
so that's why it is aligned to that. And here is closer. The arrow's closer end is south, right?
Hmm.
That's why its arrow should be like this. So it's matching with the field lines, and also with that rule that like poles repel and unlike poles attract.
Hmm.
Is it clear now?
Hmm. Hmm.
Kind of,
No,
or
completely.
completely clear, completely
Hmm.
satisfied, right?
Hmm.
Now, okay, now here we are using that rule only, the one we just discussed now, that field lines start from North Pole and is into the South Pole. So arrow is always showing us North Pole, right? Arrow is representing us North Pole direction.
Hmm.
Is it clear now?
Hmm.
That one, yeah.
Hmm. Hmm.
Then next,
Okay. Wait, sir, 1 minute. The arrows on the arrows always represent not full. So what changes would be done on the question if the answer was South Pole?
No, it will not be South Pole.
Okay,
Always field lines start from north and into the south. That's why direction of arrow is always north.
okay, okay. Hmm. Yes, sir. 12.
12. These all are correct, right? 11, till 11.
Yes, sir.
Okay, very good. Now, 12 you answered or you did not?
I didn't.
Can you read?
A metal bar PQ hangs from a thin thread and always comes to rest with end P pointing north. Another bar XY from the same metal settles in no definite direction. What happens if the two bars are brought near one another?
Okay, so you draw it. PQ, PQ you draw and it's pointing north. That means its right side is North Pole, okay? And left side is South Pole. Draw one bar magnet here and label North Pole and South Pole.
Done. Done.
Okay, so another bar XY of the same metal. So underline here, same metal. When they are saying same metal, that means it is magnetic material. It is a magnetic material.
Uh, with P ending north. Wait. Let's see. Sir, if the north pole is we are taking like at the front, like up and down, we are below N. I'm giving P and Q, a bar magnet PQ with P facing north and another bar XY of the same metal settles in no definite direction.
Now you underline here same metal. Where it is written
Hmm.
same metal, you underline there. Then just below it, you write here, it's a magnetic material.
Sir, how do we know that this is a magnetic material? Because of
Without
same
being
metal.
a very good question, and actually, I wanted to ask you this question. Before that, you asked me. I wanted you to think and say the answer why it is magnetic material.
Um, Because magnetic material is
Yeah,
only
without
acts as a
without
magnet.
magnetic material, you cannot make a magnet. Is it clear to you?
Without magnetic material, we cannot make a magnet.
Yes, you must need a magnetic material. Maybe it is hard magnetic material or maybe it is soft magnetic material, but it must be a magnetic material. Otherwise, you cannot make a magnet. It must be out of iron, steel, copper, nickel, any one of them. Right?
Hmm. Hmm.
Is it clear?
Yes, sir. Hmm.
Okay, now no definite direction. Settles in no definite direction. You underline this part and
Hmm.
in bracket you write here because it is unmagnetized. Because it is unmagnetized.
The magnetic material is unmagnetized.
Yes, still that means it's yet to be magnetized, right?
Magnetized.
It is still
Hmm.
not. It is magnetized. That's why it does not have any definite direction. So you wrote.
Hmm.
Then you think which one is your correct option. It is a nice question.
I think so. It should be A.
Correct.
Yeah.
Then I am satisfied that I could make you understand.
So can I explain to you? I think so. My idea is correct.
Okay.
I answered A, like I was having. Uh, since magnet bar, I mean the metal bar PQ attracts north. I mean comes to rest pointing north. So I think so. The metal bar PQ is a magnet.
Yes, of course.
So if a magnet attracts, I mean a magnet will definitely attract a magnetic material, no matter if it's in a opposite, if it's in x direction or y direction, right?
Yes, yes.
So the metal bar, I mean the bar PQ, since it's a magnet, so it doesn't matter if I like attract it through P or through Q, it will still attract the
Yes.
index.
Again,
Yeah, got it.
again, why also like that? In P and Q both attract in Y, right? But that option is not here. available. If they are giving you that option, that is also correct.
Hmm. Second, repeat which option? I just forgot that option.
In P and in Q, both attract in Y. Just place
Hmm.
in A place of X, you just above you write Y. That's it. Or you just give here slash, then write here Y. That will be more fine.
Hmm.
Done?
Yes, sir. Hmm.
Which one you are doing now?
I mean 14.
Okay, you think, I think you can do it or now.
I mean, how do I say this? If the direction of wire is the direction of current is through the wire, so I must use this right hand rule,
Right hand grip rule.
right hand grip rule.
Yes.
So if I put my thumb through the, and if my hand is going like I think so clockwise,
No, class is going on.
sir, is it A?
No. You draw magnetic field lines there.
Sir, if I use the right hand grip rule, so the direction is coming like clockwise, like
Okay.
through from where I'm sitting. Like,
Okay,
the way
you,
I am
you,
facing.
you draw clockwise, then you give the direction.
Yes, sir, I did.
Then you found it.
Yeah, from my point of view, I think it's A.
So can you annotate on the screen? But my one is different. You're trying.
Yes, I tried. I think so it's A.
Look, I'm drawing only a single line.
Hmm.
Okay.
Hmm. Oh, it's a compass needle. It should be it should be C C. Yes, shouldn't it be C?
Yes.
Yeah, I got it. Got it. I got it.
The next,
Yeah, 15.
Amjad, next.
Yes, sir. 15. Hmm.
Okay. I think you can do it now.
Uh, wait. What's the line? So what's that line in the middle? Is there like a border?
Repulsion. This line is showing you repulsion.
Okay. If that one is going inside, wait, how do you say, clockwise, and that is coming outwards, so it's repelling. A or same direction, it will opposite direction attract. Same direction repel. If this one is going this way and it's going out of the page, then it's coming this way. So it's in the same direction, so it will repel. A is repulsion, Uh, so definitely not B. Uh, uh, A is repulsion. Sir, will it be C?
Yes,
Sir, does A make any kind of sense?
this is actually uh,
It doesn't
they,
make any
they
sense,
are
right?
A and C. You can check. They both are similar except the arrows.
Hmm.
In A, the wrong is they are showing the arrows as attraction. Actually, this is repulsion, right? That is wrong.
Sir, A is repulsion, right? But the arrows are showing attraction,
Arrows
so
are
it doesn't
shown
make any
wrongly.
sense.
Arrows are
Hmm.
shown wrongly. That's why we cannot choose A.
Hmm.
Right.
So now 16, right?
Yes, you are done with 15, right?
Hmm.
So you understood. Now you can do
Hmm.
also 16.
I feel kind of happy.
Now you are becoming expert.
Yes, like I was facing the same problem in radioactivity. Two parallel wires carry current in a opposite direction. In a opposite direction. So definitely I need to use the right hand grip rule here. Uh,
Of course.
Three plotting compass are placed at the position as shown. Oh, I need to draw the magnetic, what do you call that, circle, the shells. I need to draw the shells. But how will I draw the shells if there is like one in this way and one in that way? The
No
current in
problem.
both
No,
wires.
you draw
Like
the rule you know. Then you check.
okay. Sir, is it zero? Is it A?
How many compass needles change direction?
Zero.
Both the wires reversed. Did you check with the rule?
Yes, I drew the circles also.
Did you see it? The currents in both wires reversed.
Hmm.
So if you reverse the current, then what will be the direction of the field lines? Will it be same or it will be opposite?
Wait, I didn't get you.
I'm saying if you reverse the current, ah,
Sir, it's same, right?
how same? If you
I
reverse the
mean,
current, the field lines Direction also will be changed. For both the
Okay,
wires, they are changing. You check. Then after
that's
checking,
that
you
both wires are reversed. I mean, like, last, I'm kidding. So it should be three, right?
yes. P means D, right? Dhaka.
Hmm.
Now you understand.
Hmm.
Still, kind of or clearly. Is it clear or you have
Yes, sir.
doubt
Yes, sir.
still? Did you draw?
Yes, sir. Hmm.
Are you confident?
Hmm. Hmm.
Then next, go to next. What is next?
Sir, can I just go to the washroom? One minute.
Okay, okay, sure. 17, yes. 17, read, then think.
Sir, can I rejoin? Your voice is coming, breaking.
Okay, okay,
Ready, yes.
okay, sure.
Hmm.
Battery P is disconnected, right?
Yes, sir. Hmm? Yeah.
If
Why is
if
the P
battery
that it's
if battery P disconnected, what happens?
uh
First, you think if it is connected, then what happens? Then you can understand if it is disconnected, what happens.
sir, I don't have any idea. I think so. I did not learn this part. Was it in?
You do not need to learn this part. Without learning from the diagram only you understand. And you learned one thing, that is uh, electromagnet, right?
Hmm.
Solenoid.
Hmm.
If electricity is going through a solenoid, then it becomes temporary magnet, right?
Hmm.
You know that one. So
Hmm.
it's the idea of temporary magnet. That's it.
Sir, is it A?
Iron armature falls, bell rings. Yes, correct. Is it is it very difficult question? Circuit.
Uh,
If you see the circuit, it seems it is very difficult question. Actually, the concept is very easy, simple.
I mean, sir, can I say my concept, my point of view?
Yeah. So it is
Hmm?
correct. Your answer is correct. A.
Sir, why is it not D, Dhaka?
Okay. Why it will move up? It will only moves up if iron core is magnetized. If iron core is magnetized, then it can attract the iron armature, right?
Hmm.
Then iron armature can move up.
Hmm. Also, when the battery is down, the iron measure falls and it drains the bell. Yeah, got it. Hmm.
Yeah. It's like relay circuit. Can you remember one thing we
Hmm.
learned? Relay circuit. So
Hmm.
here we are getting also relay circuit. That the iron core one is working as the primary circuit, and the iron armature one, that one is working as the secondary circuit, right? The bell one.
Hmm.
So it is one of the examples of relay circuit. So you can write here beside this circuit, you can write it is a relay circuit.
Hmm.
So done.
Hmm.
The next, next which one?
Hmm. I think so it's 19. Oh, no, 18, 18.
18 you can do now, right?
Yeah, yeah, hope so. So is it C?
Yes. Then what about 19?
Yes, I'm thinking about it. It should be B, right? Yeah, B.
Right. So you see how expert you are becoming now, right? Very much expert.
Alhamdulillah.
Alhamdulillah. Now 20.
Hmm. The 20 I did. It should be C, right?
Yes. Correct. Awesome. Great. Then structured part.
Hmm. So I think so I can do the structured part by myself for now. Yeah.
Yeah,
I
you
need
can.
to know about that electromagnet. I had some problem with that electromagnet.
So we should we continue the worksheet or we should start the new topic?
Sir, I wanted to uh, know about the. I wanted to start electromagnet and its condition and all the stuff because I didn't understand anything about electromagnet.
That
That's why I
means
wanted to talk
from
about electromagnet.
from this worksheet or the new topic.
No, from the new topic. Like I
Okay.
need explanation on electromagnetism. That's it. From
Yes.
worksheet, from topic, doesn't matter. Just need an explanation.
No, no. I'm talking about this worksheet or this topic. You have electromagnet that part or new topic.
This part.
Okay, this part. Okay, electromagnet. We got the idea in right hand grip rule. That one is giving us the idea of North Pole, how it is created, right?
Hmm.
So that idea we'll use. You have, I think, one note in your copy. If you take that, if you uh, pass some current through wires and inside the wires there is one iron core, then this iron core turns to a magnet, right? So this iron core is becoming magnet due to electricity. That's why it is called electromagnet, and it is
Hmm.
temporary magnet, right?
Hmm.
And temporary magnet means if you stop the current, then it will no more magnet.
Hmm.
So it is a basic idea. And the other one I told that how to have the poles, north pole, where it will be north pole, where it will be south pole. It depends on the direction of current you are giving.
Hmm.
Yeah. So that one is also possible to get using the uh, right hand grip rule. Right hand grip
Hmm.
rule, if in this case the thumb is showing you the pole and the other fingers direction is showing you the current direction through the wires, because here we are not getting a straight wire. Here we are getting wires with loops, right?
Hmm.
That's why our other fingers are showing the direction of current and the thumb is showing us the north pole direction.
Hmm.
So is it clear now? The
Yes.
diagram you drew, you check with the one I just now described.
Hmm. Sir, elect, what does actually electromagnet consist of? Iron
Yeah,
or
electromagnet is consisting of soft iron core. In core we have iron, and
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 that wire is the current.
over the iron we have insulated copper wires. Through wires we are passing the electricity. Okay, and when we are
Hmm.
passing electricity, that electricity, that can create magnetic field, right?
Hmm.
Magnetic force it can create, and using this magnetic field lines we can have north pole, right? So which direction will be north pole?
Hmm.
Is it clear now?
Hmm. Hmm.
So did you write anything about question 1 A B?
No, sir. I gave up when I couldn't do the MCQs.
Okay, that time you stopped it, right?
Yes, I
now
gave up.
now you you can see that the questions you are getting, these are familiar with, right? Question
Hmm.
one
Hmm.
A, and state
So,
the
what is
nature.
the compass needle made up of actually?
It
You
is
didn't say me that.
permanent. It is the compass is
Okay. Iron.
permanent magnet. So compass needle should be made from either steel,
Iron, copper,
cobalt,
nickel.
or nickel. Cobalt, nickel, or steel. It's not
Hmm.
from iron.
Oh, okay.
Okay, as iron is used for making the temporary magnets. Iron is soft magnetic material, so should not be compass needle. Is it clear now? Hello?
Yes, sir. Yes, sir.
And
Clear.
next one, describe how the small compass is used to plot magnetic field lines in the region surrounding the magnet. So we can use the compass to plot magnetic field lines. How?
We can move it around the magnet.
Yeah, we can place it at different positions, and we will check out the direction of North Pole, and there we will give the direction of arrow, right? Isn't it? We will draw the
Hmm.
direction of arrowhead over there. So after finishing all this, then we will join all those lines, okay, to get
Hmm.
complete magnetic field lines with direction.
Hmm.
Okay, is it clear?
Yes, sir. Yes.
Okay. This way you will write all the things in 3 points.
Okay.
Then this one you can do, right? Already we got the idea in MCQ.
Hmm.
Then this one, very simple. Huh? Question one, you understand it?
Hmm. Question one. C. Why
Yeah,
is the iron bar attracted to the magnet?
yeah.
Yes, because of when it comes since the magnetic field line, since the
Then
magnetic
iron bar becomes magnetized, right?
yes, and
And
the
it's
magnetic field is
behaving
so
like
strong.
magnet. Then we are getting here North Pole, and this side Q, we are getting South Pole, right?
Hmm.
Then South and North, they are opposite poles. They are attracting each other.
Hmm.
Is it clear?
Hmm. Yes,
Now
sir. Now
two you
questions
can
like
do.
two, I don't know anything about.
Two you can do now. They said you some information. Ah, they are giving you some information that the switch is closed and there is an electric current in the solenoid. And W of flexible iron strips, WX becomes a magnetic south pole. So W you are getting south pole, right? So
Hmm.
X will be north pole. It's pretty sure, right?
I didn't get it.
Because a single bar only, right? Or say single stick of iron only. So if one side is becoming south pole, the other side will be north pole, right?
Hmm.
Of the iron. It is the property of any magnetic strip or magnetic material. If you are magnetized it, that one side will be north pole, another side will be south pole,
Hmm.
isn't it?
So, sir, are we considering that W is not South Pole?
Yeah, is they gave it. Yeah, they said you in W of flexible iron strip double X becomes a magnetic south pole.
Oh, okay.
They already told us.
Hmm. So X is definitely N.
Yeah, N pole. Then
Y
if
will
it is
be
N
S
pole,
because
yes, Y will be S again,
that
and Z
Z
will
will
be
be
again.
N.
So this way you understand, right?
Hmm.
So you can write them. Then second part also you can do.
Because sir, wait, what happens to X? They attract. They
Explain what happens to X and they will attract, right? They will attract each other, right? Then next, B about relay.
hmm.
Hmm.
Relay operates a switch in a relay operates a switch in one circuit using the current in different circuit. State one
Yeah.
example of a relay used in this is how I relay is used. Sir, I did not understand anything from here.
Yeah, they are saying relay operates a switch in one circuit using the current in a different circuit. So already you have the idea how relay is working. You are giving current in one circuit, then other circuit is working, right?
Hmm.
In one of the MCQs, you already got the example also how relay is working. And during our discussion, I told you about power stations. I told you about uh, the starting of a car, right? Car engine. Can you remember that one?
Hmm.
So you just give one example and how it is working. You can also describe.
Hmm. So, sir, can we
Hmm.
uh, pause here today?
Yeah, state one example of relay used in this way and, and explain why a relay is used. First thing you give example and you will write the reason why it is used there. So you if you are writing, I'm giving you two examples. Okay, the first one is for a starter of a car, right?
Hmm.
You write example here, make a table. In first column you give the heading example, then you write here reason. Okay,
Hmm.
so the number one, you write starter of a car, starter circuit of a car. Then here you write to avoid electric shock.
Starter of a car
Yeah, and why we are using the small circuit to avoid greater electric shock, right?
to avoid
Because
greater electric shock. Hmm.
okay, then second one, in power in nuclear power station we are using relay circuit. Why we are using to be safe from radioactive, uh, you know, radioactive hazards. To be safe from radioactive hazards.
Hmm.
So is it clear now?
Hmm. So, sir, I can give any one, right?
Anyone,
First,
anyone. You for writing example, you are getting 1 mark. For reason, you are getting
giving
another mark.
another one.
Okay. Then next, three. Yes. Next.
Yes, sir.
Yes. Continue this one.
Yes, I'm seeing. I'm reading it. So, sir, is this another? Oh, it's an electromagnet. Okay.
Yeah, they are giving you information. The current in the solenoid magnetizes the iron core so that the lower end of the core is north pole. So you give here label here north, lower end. So if it is north pole, then you can understand the field lines, right?
Hmm.
You are drawing here north, that means here is south. So you can now draw the field lines from north to south. You should draw at least four field lines with arrow direction. You will show the direction of arrow.
And sir, shouldn't it be left?
What left?
Like the arrow should be left, right?
Left means what? Arrow should go from north to south. That one will show you upward direction of field lines. Is it clear? Here
Wait, sir.
is here is north, here is south.
Hmm.
So field lines will go from north to south this way, and you will give here arrow this way.
Wait, sir. Sir, they said there. Oh, direction of magnetic field. I gave the direction of current. Okay, okay, no problem.
Mhm.
Yeah, the direction of magnetic field should be from north to south. Hmm.
Yes, yes. They are saying you to only give direction of magnetic field lines.
Hmm. So, sir, I should give four, right?
Yeah, four. Left side for two, right side two, and you show the direction of arrow.
Okay. Hmm. So, sir, can we stop here today? or
Okay, okay. If you want to stop it here, I think we don't have anything more difficult here. You can do the rest part, right? If you try,
mm, okay,
try them, huh?
mm, okay, sir.
Try
Allah
them
Hafiz.
and you send me the notes, huh?
Okay, okay,
Okay, okay. Thank you, huh?
okay,
We
sir.
will
Allah Hafiz.
continue on we
Tuesday.
will on Tuesday, right? Okay. On Tuesday
Okay,
we'll
sir.
continue. Allah Hafiz, huh?
Okay, Allah Hafiz, sir.
So.
Walaikum assalam.